Today we're going to look at how to use like terms to solve our squares and rectangles problem. The first step is to realize what the rules of the game are. This square with an x in it doesn't look like a square, but we're going to assume it is a square, which means the length of all four sides of that square are x. And this one with y would mean that this length is y, this length is y, this length is y, this length is y. Now, whenever we have squares that line up against another square, like this, the lengths on one side have to equal the lengths on the other side. So since this length here is x, and this length here is y, the entire length on this side must be equal to the sum, x plus y. Taking a look at the next one, if this is 2y, and this is 2x plus y, this one has to equal 2y plus 2x plus y. And we can combine these, remembering that y is 1y, so we've got 2x plus 2 plus 1 gives us 3y. Over here, we've got the same thing happening, but we've got 3 of them. So we're just going to combine all of those. We've got 2x plus 3y plus 2y plus x. The x is 1x. We've got 2x plus 1x gives us 3x plus 3y plus 2y gives us 5y. Now there are situations where we have two boxes lined up with two other boxes, like right here, and it's a little bit tricky to figure out what the fourth box has to be. So we are going to use a little bit of algebra, but the process is still the same. We take the boxes on one side of the line, in this case the top, which is 2x plus x plus 3y on the top, and that has to equal whatever's on the bottom, which is 3x plus y plus this mystery box. Now, combining on each side, on the top we've got 2x plus 1x is 3x plus 3y, and on the bottom we have 3x plus y plus our question mark. Now, we can subtract the same thing from both sides of any equation. If we subtract 3x, we know that 3x minus 3x is 0x, that disappears. And the same thing over here, and we're left with 3y is equal to 1y plus the question mark. Subtracting 1y from both sides shows us that the question mark has to be 3 minus 1, or 2y, so we can go ahead and put 2y in this box right here. Now that we understand the basics, we can use this to complete this puzzle number 1, which I'd like you to print out and do along with me. As we go, we're going to actually highlight the lines that we use, and when we get a little bit into the next module, you're going to see why this is an important process. So we have this line, we have an x and a y on the left, therefore the box on the right must have x plus y in it. Now if we go down, we have a line and the box is on top, we have x plus y. That gives us a total of 2 x's plus a y. If we instead went up, we have y plus x plus y. So we've got the 1x, but we've got 2 y's, one from each box. Let's come down here in the middle now. We've got on the right side x plus 2x plus y. Since that's a 1x, 1x plus 2x gives us 3x plus y. And now we're kind of stuck unless we go here. This is one of those situations I was talking about just a moment ago, where we have two boxes on the top, two boxes on the bottom, and we've got this mystery box. So on the side we're going to set up the equation for the mystery box. We know that mystery box plus y has to equal 3x plus y plus 1x from the boxes on the bottom of the line. When we go ahead and combine the like terms, we see that mystery box plus y has to be 3x plus 1x gives us 4x plus y. And now what we've got to do is simplify this, and we can realize that since we have a y on both sides of this equation, we can go ahead and subtract those y's. They conveniently cancel out in this case, and the mystery box is equal to 4x. So we can put 4x in that mystery box. Now, finishing it up, we use this line. We have 4x plus 3x plus y. The x's combined. 4x plus 3x gives us 7x plus the y. And we've got this line here. Combining the 7x and the 4x gives us 11x, plus we still have the y from the lower left-hand corner. And you'll notice there is one line we have not used yet. There should be one line left over. That's the line that's going to be important in the next module when we use the algebra to solve the equation. So there you go. Please go ahead and try this on puzzles 2 through 5, and that is your assignment for this module. Thanks. Bye.